Hello, and welcome to Lives of Water Part 1, the first in a series of videos on water and creative cartography hosted by Jakmel Ekspresyon. My name is Trevor Even, and this project is brought to you thanks to collaborations between myself, Professor Carly Trott at the University of Cincinnati, Sue Frame, Jean-Pierre Peterson, and Jean Stanley Bichara at Jakmel Ekspresyon. Our goal in this series covers three main areas that have emerged as being important to us based on discussions we've had as a team, as well as courses that have been offered over the last several years that have focused on local water issues, community mapping, and the challenges of community water management in Jacmel. The first topic, of course, is water, which is the subject of the video today. Here, we're going to cover just some of the basics, but our goal is to start to talk about how we understand water, the many roles it plays in our lives, and a few of the dangers and hazards that need to be dealt with in order to ensure we have the water we need. The second topic is mapping water data, where we will learn a bit about how professionals and researchers gather and analyze information about the grand, complex, and multi-scale processes that are involved in the lives of water, and how we might work in our communities to utilize these approaches. The third topic, building water maps, is where we will walk through some of the tools we can use as collaborators to take information, emotions, and ideas about water and other critical systems and turn them into informative, educational, and impactful maps and other types of documents. Because ultimately, our goal here is to help you at JE to use creative science communication as an extension of your other endeavors to change how people are thinking, feeling, and acting within water systems and about water issues. With that in mind, let's begin our discussion on water and water concepts. Because although the many processes and properties of water causes it to involve a huge array of topics and information that we might learn about, what we can hope to achieve here is a basic understanding, and more importantly, a common language of how water operates in our lives and how the systems of life and human enterprise that interact with water are tied to one another across space, from our bodies and homes to the atmosphere above us. Because no matter who you are or where you are, water is a part of your life. At the simplest level, your body, your skin, muscles, blood, and marrow, is primarily composed of water, with around 60% of all tissues containing liquid water. To stay healthy, you must take in adequate amounts of water every day, something we primarily do through the consumption of food, beverages, and water. Similarly, when we use medicine, tend to our gardens, clean the house, bathe, or mix together chemicals for work or for art materials, or even decide to go for a swim in our time off, we rely upon water and its unique properties to make things we need and to do the things that we need to do. And just as it's essential to most aspects of our lives as humans, it is also critical for the functioning of trees, grasses, plants, and organisms in nature, the things that make up the environments around us and that we rely upon for food and animal products. In a place like Jacmel, with access to the ocean, it also provides a means for travel and all of the benefits that life in the sea can bring us. Put more simply, it is often said that water is life, whatever your particular life might look like. From the tiniest bacteria to the largest whale, from the poorest beggar to the wealthiest oligarchs, you won't get much of a life without water. The reason for this is quite simple. On Earth, life as we know it is deeply connected to the chemical properties and natural abundance of water and its dynamic behavior as a component of the physical systems of our planet. Chemically, it is composed of two hydrogen atoms and one oxygen atom, bound together through covalent bonds, in which the oxygen and hydrogen atoms share electrons to stabilize the repulsive and attractive forces between their atomic cores. This gives it a number of unique properties that allow it to interact with other chemical compounds in a number of important ways. For our sake, however, what is most important is that within Earth's atmosphere and the resulting temperature range created by our position relative to the Sun, water can readily shift between its solid, liquid, and gaseous forms. As we will discuss in a moment, This has profound effects on how it moves through Earth's living and non living systems. At the same time, however, it's important to remember that down to the tiniest strands of our DNA, the chemical properties of water and its constituent atoms give it a role in nearly every process that keeps our bodies and the bodies of other living things operating effectively. As a result, contaminants of water, such as chemical pollution, have the ability to find their way into the most sensitive systems within us. Understanding how to protect water in our environments and lives requires us to first understand how water moves around the world. For while our experience of water always takes place where we are and live, the processes that link together the waters of the oceans, the rain in the sky, the rivers, lakes, and streams on the land's surface, and the groundwater deep underground all take place at a global scale. Powered by the sun and stirred into motion by the differential rates at which parts of the world near the equator and poles are warmed, all of the world's weather is part of a great global pump of water and other atmospheric gases, moving them around the world and forming the massive storms, gentle rains, and dire droughts that shape our lives and have the ability to affect our well being. For example, here is a view of Haiti and the surrounding oceans and nations taken by the GOES or GOES 16 satellite on May 2nd, 2021. Positioned roughly 37,000 kilometers above the Americas in a geostationary orbit, the GOES 16 satellite provides near real time imagery of the Earth from space, allowing us to see, among other things, the dramatic movement of clouds, which are essentially water, as moisture from the Amazon forests and oceans climb up into the atmosphere, condense, and ultimately fall again to the Earth as rain. It is these same processes of water movement between the land, atmosphere, and oceans that produces hurricanes and other massive storms, such as Hurricane Laura, seen here at center on August 22nd, 2020. Although a relatively weak tropical storm when it struck Hispaniola, it caused massive flooding across 28 communes and 4 departments in Haiti, killing over 30 people and damaging almost 9,000 homes across the country. In other words, the same processes that give us the water we need can, under the right circumstances, bring tremendous danger and destruction. Because however you are encountering water, whether as a cloud in the sky, a hurricane on the horizon, or as a glass of water on the kitchen table, it is always caught up in a great process of transformation and movement that scientists refer to as the water cycle, or more technically, the hydrological cycle. Though the water cycle has no distinct beginning or end, most of the water on Earth, 97% in fact, is found in the oceans, where it exists primarily as liquid salt water or salt dissolved in water. There, as it is exposed to radiation from the sun and pressure from the wind, it evaporates into the sky, where it then condenses to form clouds that move across the oceans and over land. As it moves across the land surface and interacts with different types of topography and surface temperatures, it has the opportunity to further condense until it reaches a point of saturation and begins to fall to the earth as a liquid rain, or, if it is cold enough, crystalline snowflakes. Although I do not think you get much snow in Haiti. Once water falls to the earth as rain or snow, it then moves over and through the land, forming rivers, streams, ponds, lakes, and lagoons on the surface. It also moves underground, where it may be taken up by plants or soil microorganisms, or move deeply into underground aquifers, where it becomes what is referred to as groundwater. Of course, this is only a simple overview of the many processes that take place within the water cycle. Hydrologists are scientists who study different aspects of water's movement across and through landscapes, and you can spend a whole lifetime figuring out the intricacies of water's behavior in different situations. What is most important, however, is that it is only through the cyclical transformation of water that we have access to freshwater resources, and through which we are able to live our lives. And that global processes, operating at multiple spatial scales, are critical in shaping the day to day experiences and challenges that we face. One of the most important aspects of our environment that determines how we interact with water is the topography and geology of the land surface around us. It is the land, after all, that receives the water released by the atmosphere. And depending on how the land around you is shaped and what it is composed of, that water will behave differently. Because water always follows the path of least resistance and on Earth always follows the pull of gravity, the slope of the land around us is one of the most important factors in determining where water will go. Of course, if the land is porous and water can be absorbed easily, it will soak directly into the ground. Likewise, if it is dry, compressed, and hardened, or if it is covered by man-made materials like concrete that do not allow water to penetrate, the water will simply slide over the surface and move downhill. The places where all this takes place are referred to as basins, and within basins, watersheds. These are simply the total area of land that drains to a common point based on its topography. Much like a wash basin or bucket, it is an area that is effectively enclosed on all sides, and in which water can only follow certain routes to escape to either another area downstream or to the ocean. For example, the three rivers that converge just north of Jacmel are fed by a basin over 500 square kilometers in size, which is shown here outlined in orange. Within this basin are multiple sub-basins, which comprise the total drainage areas of major streams, such as the Rivière Gauche, the Rivière La Gosselin, and the upper reaches of the Grand Rivière de Jacmel. These major streams are fed in turn by smaller streams, whose basins are referred to as watersheds. Within these watersheds, sub-watersheds are also found, which contribute to the small tributary streams found in the mountain valleys leading towards larger streams and rivers. And just to note, this map of the Jacmel Basin was developed using new high-resolution elevation data gathered in 2018 by the Haitian government, and that I have processed for our use in the class. As far as I know, this dataset has been too large to effectively download until now, making us the first class, potentially in the country, to be working with this pretty incredible dataset. So more to come on that. Another important concept in understanding how water moves across the landscape is the idea of the stream hierarchy or stream order. Although there are many different ways of talking about surface water flows, here I have shown what is known as the Strahler stream order hierarchy. In it, first order streams, marked with a 1, are those that have no meaningful tributaries. These are often high elevation mountain streams. Second order streams are those that are fed by 2 or more first order streams. Likewise, third order streams are those that are fed by either multiple second order streams or second order and first order streams. Fourth order streams are then those that are fed by third order and lower streams. This classification goes on and on. For example, based on my own analysis, the Jacmel River could be referred to as an 11th order stream by the time it empties into Jacmel Bay. This means that effectively thousands of individual smaller streams spread across the basin are all connected by flowing water above and below ground, only to enter the ocean right beside your town. And depending on what happens to that water as it moves through the broader basin, the water in the Jacmel River will have different properties and will flow at different rates. Put another way, the quantity and quality of the water that arrives at the lower Jacmel Basin is shaped by the features of the landscape found across the basin as a whole. One of the most important factors in how landscapes affect water is how much of the land is covered by natural vegetation and what types of vegetation are present. In all cases, however, vegetation operates as part of the water cycle in a number of interesting ways. First, plants drawing water from the soil release water vapor through tiny holes in their leaves in a process called evapotranspiration. They do this both to maintain their temperature, just like how humans sweat, and to release excess water created during photosynthesis. This has the added effect of cooling the air around the tree and reducing local temperatures, especially in cities. Trees and other vegetation also intercept water falling from the sky, acting like an umbrella and shielding the soil underneath from direct impact from raindrops and slowing erosion. When water flows over vegetated areas, it is able to more readily move into the earth and enter groundwater reserves through the process of infiltration. Vegetation speeds this process thanks to the plant roots, which act like tiny channels that water can slide down. This means that, in addition to recharging groundwater, plants also help to mitigate the risk of sudden flash flooding during extreme rains. The roots and surface cover from vegetation also work to stabilize soils during rainfall, which overall reduces risk of mudslides and also reduces the risk of the amount of water and sediment and other bodies and other surface contaminants that make their way into water bodies like ponds and reservoirs. What this all means is that if you have healthy forests in your watersheds, you can generally expect fewer floods, less intense floods when they do occur, and overall better water quality. If areas are deforested, you will likely see worse floods, more polluted water, more erosion, and higher risks of landslides. This is just one more reason, of course, why deforestation in Haiti represents a true crisis. With almost none of its primary or old growth forest remaining, it is essential to find some way to untangle the complex challenge of reducing forest clearing and promoting new forest growth in order to ensure that Haiti can use natural systems to improve its water availability and water quality issues. It will, of course, not be as simple as asking people to simply stop cutting and clearing the forest. With small scale farming and charcoal burning continuing to be critical parts of the local economy and resources for planting trees limited, imagining more and abundant functional forests in Haiti will require both research and creativity. Humans also alter water systems at the basin scale through other activities other than direct changes to natural ecological function and forest health. Indeed, the main way that water becomes contaminated is through different human activities, as we will discuss in more detail in a bit. But for now, let's just consider the many different ways that humans in the Jacmel Basin and most places in the world interact with water by following water as it moves downhill from the mountainside and through the human ecology of the basin. First, it passes, in most cases, farms. Here, vegetable production, grain production, and livestock all require water and take up water from the soil as part of the growth process. Some farmers may irrigate their crops, while others rely solely upon the rain. However, in both cases, the land cleared for crops takes on new hydrological characteristics, generally becoming more prone to erosion and more likely to be transported during heavy rainfall episodes. Farms may also utilize pesticides, herbicides, fertilizers, and other chemicals that may seep into local water supplies on the surface and underground, and may over time result in the salinization, that is, turning fresh water into salt water, as excess fertilizer is converted to salts in the soil. In rural villages, human waste, trash, ash from fires, and other contaminants may come into contact with water sources due to a lack of proper waste management systems. Small rural villages may also be prone to flooding issues as they are sometimes located close to running water for the convenience of access. In many towns and cities, industrial activities are also a factor in how humans interact with water systems, as they can produce a wide array of chemical contaminants depending upon the industry, and may also require large amounts of water to operate. Water treatment and sanitation systems, whether they are small and localized or large utility scale operations, also play a huge role in water, as they can determine whether day to day human activities have negative impacts on water systems and whether water is utilized in a way that makes it safe to drink. Because most of the systems for this are at the household or building scale in Jacmel, it becomes ever more critical that good practices are well understood and widely utilized, as small problems at the household scale can add up quickly at the scale of a whole community. This is also true of the surfaces, materials, and processes taking place within dense human settlements, as we will discuss in a bit. Thinking of these different land use types, I tried to highlight areas of the area around Jacmel to point out just where we might see different human activities affecting the basin. For example, within the city of Jacmel, we are largely concerned with the many surfaces and land uses found in the greater city area. To the north of Jacmel, however, hillside farms and villages are the dominant land use. Further up the basin and to the northwest, steeper hillsides mean that relatively more forest cover and less farming activity are present, but both are still there. Each of these areas together have an effect on the water that flows into Jacmel Bay. As a result, as we try to think of water solutions, we have to consider many different processes feeding into the problems we face. Another factor of complexity in how humans interact with water comes from the way that we build our cities and homes, and the surfaces that urban areas present to precipitation falling to earth. In this image of Jacmel, we can already see some of the diversity of surfaces within an urban area. Near the river, gravel and sand allows water to move freely and may move with strong river flows. Where streets are paved, however, water will infiltrate the ground much more slowly or not at all, causing it to flow across the surface and accumulate nearby. If roadway drainage is insufficient, roads can easily become paths of least resistance for water, transforming into waterways during extreme rain, and carrying with them debris and chemicals from near businesses and homes. Similarly, concrete, which is used extensively in Jacmel as a building material, does not allow water to soak in unless carefully planned, and can cause water to pool and accumulate in unwanted ways. Gardens, treed areas, and other vegetated areas can play many roles within a city, including allowing water to move more slowly and to infiltrate the ground rather than flowing across the surface. Green spaces with healthy soils can be thought of as what is called green infrastructure in this way, as they can play a role in planning the way water moves through your community and the land you live on. Rooftops and plazas, such as the Plaza Jacmel shown here, also have to drain properly in order to function. Because they often cause water to flow away rather than soak in, they can also cause flooding in areas nearby if they are not carefully planned. Part of why we focus so much on how water flows over and through human communities here is because it is there that most of the types of water pollution that are most concerning occur. At the easiest to understand level, we have things like solid wastes, such as garbage, plastic, large accumulations of organic matter, such as from animal processing, and some components of the sewage created in homes and other places in lavatories. Another type of contaminant, sediment, can also occur naturally, but is most often an issue when humans disturb the land or accumulate large quantities of different aggregates, such as for building. Sand, small rocks, soil, and so on can cause filtration systems to work poorly and may carry other contaminants. Toxic chemicals, such as lead, used in older paints and many industrial applications, chlorine, arsenic, other types of mining process runoff, and many others, are substances that are harder to see and often require special tests to identify. However, their effects can be serious and deadly, and in many cases accumulate over time in the body to create increasingly serious medical conditions. Pathogens, such as bacteria, viruses, and parasites, are another type of water pollution. Often carried by humans and livestock and pass through feces, these types of contaminants can be addressed with both treatments like boiling and by proper sewage management. Many pathogens found in water can cause miserable and deadly diseases, such as cholera and typhoid. Nutrients are another important class of water pollutants and represent specific chemicals important to biological activity that can cause significant ecological impacts and alter water chemistry. They include chemicals like nitrogen, phosphorus, iron, and potassium, and come from a number of sources. Fertilizer, compost, and manure can all cause nutrient pollution, but it can also be produced as gases resulting from automobile operation and industrial activity that get brought back down to Earth through condensation in high elevation areas. So let's have a look at something real and see what we can identify based on what we've learned. This picture was taken 2 years ago by students in a previous class on water issues at Jakmel Ekspresyon and is just north of the Jacmel harbor. First, and perhaps most obvious, is the solid waste contamination, or trash and other debris that is washed up on the shore. Some of this plastic pollution and other garbage may have come from the ocean, with origins far away in the Atlantic. Others more likely wash out of the Jacmel River or were deposited through other mechanisms like wind. Although it does not break down chemically, plastic will eventually break down mechanically into tiny microplastic particles, which can have a number of negative effects on human and animal biology. Here we can see also an example of some erosion, as this tiny bit of grass is worn away. Though not a major issue here, in other areas it can result in muddy, unusable water, among other things. Here we may also see a source of chemical contamination from whatever fuel or other oil may remain on this disused and abandoned jet ski. Gasoline, motor oil, and other chemicals used in boats are commonly found in areas of high ocean traffic, acting as contaminants in those areas. In another area nearby, where burn pits were found, we can see examples of numerous types of water pollution. Here, however, we have the addition of nutrient pollution from ash and organic waste washing into the water. This changes the acidity of the water and blocks light. The deceased pig is also likely a source of bacteria that could be harmful to humans, such as Salmonella and Giardia, and may host insect infestations over time. As I said before, chemical contamination can sometimes be obvious, like in this picture here, which shows water contaminated by some sort of hydrocarbon or oil product. The rainbow of colors comes from the many different compounds that are separating out into the water beneath it. No one would drink this water because it is easy to see that it is polluted. However, many chemical contaminants do not need to be present in quantities that make it visible in order to do harm. Lead, for example, dissolves into water when it is at the right acidity and temperature and is completely invisible and largely unnoticeable to the people drinking it. Nevertheless, it can cause serious neurological problems and ultimately death. This is just one example. Others include things like insecticide, which, while valuable in agriculture for maximizing yields, can have serious impacts on the heart, lungs, reproductive organs, and can also cause cancer if exposure levels are high enough over a lifetime. Over-application of pest control chemicals is a leading cause of water contamination in many countries and also causes numerous ecological problems as well. Ocean plastic is another growing and global problem, as plastics made from petroleum products drift around the world as they break down slowly in the seas. With no major biological mechanisms of decay available, that is to say, nothing really eats plastic, it persists in the environment, and unless we do something about it, will continue to be a problem for hundreds of years to come. Industrial pollution from factories and from major transit, such as large ships, can also have catastrophic effects if not carefully controlled. This can occur on accident, such as when oil spills occur, or may happen through neglect, such as when ships are abandoned in port and fuel and other chemicals begin to leak out as rust and other damage accumulates. Nutrient contamination, like other kinds of contamination, also occurs generally when something that we rely upon, in this case fertilizers, are not controlled and utilized safely. Mostly originating from things like compost, manure, and fertilizer that can find their way into waterways, nutrient pollution can result in sudden changes in biological processes and ecosystems. Often, this results in intense blooms of algae that rapidly suck out all of the oxygen in the water and block out the sun. If it is serious enough, this can kill off fish and result in the release of pathogens and toxic poisons into the water as organisms break down suddenly. Some types of algal blooms can release toxins that harm the skin and cause intense allergic reactions, while others can make a person ill through consumption. Again, fertilizer or compost, chemical fertilizers. So, what do we do about all of this? In many places in the world, governments and communities build complex and expensive water treatment systems that utilize large amounts of energy to operate. While these systems can be effective, they are not always possible and are not the only way forward. Smaller, decentralized systems can also dramatically improve water quality and availability, but only if there are enough of them, their operating costs are low, and they are well maintained over time. Increasingly, however, nature-based solutions to water management are gaining headway, especially in the most wealthy countries, but also in areas without significant technological infrastructure for water management. Although this topic is too big to cover here, these types of systems involve actively or passively maintaining areas of high functioning vegetation and ecosystems around key areas within watersheds and floodplains. This has the effect of mitigating flood occurrences and impacts, as well as providing numerous benefits for water quality, and as water is filtered of sediment and other contaminants by living root structures and soil organisms. These also have the benefit, in many cases, of providing areas that are healthy to be near and beautiful to admire, with many of these green infrastructure systems also operating as parks. Now, we have covered a lot of topics today, and none of them have been given the attention they truly deserve, given how complex and important they all are. That said, what I hope you are leaving with today is an introduction to some of the most important concepts that we can use to begin to discuss water issues in our communities. As we look forward, however, three key notions stand out as I look down on this photo of Jacmel taken in late 2018 by the Haitian government. First, that because we live in basins that cover vast areas, and the powerful role of natural ecology in determining water system function, how we maintain natural systems and waterways determines what kind of water we get and how much water we can rely upon. Second, because we live in large groups and our lives require many things, how we utilize technology and manage potential sources of pollution as we use and reuse water is critical to our health as communities. When you put these ideas together, then, it says that we should work towards a future where, at minimum, we understand that the life of water and the lives that water enables, are dependent upon human and natural systems operating at numerous spatial scales. Because of this, we must learn how to work together to ensure that everyone has access to the water they need and that their environments are healthy and functioning in a resilient fashion. So what now? Well, first, I would encourage you to take some time to think about what we've learned today. Considering what you have thought of so far and the roles water plays in your life, what do you think are the most critical water issues that your community faces? Write these down if you'd like, and we can analyze them as a group later. Second, let's investigate a bit. We covered a lot of topics, and you likely have questions about what we've learned about. What would you like to know more about? that maybe I can help you with as we move to the next part of the class. Finally, let's be sure to plan some time to prepare for the next class, where we'll dive into how to map information about water and bring our observations into relation with other types of data sets. To do this, I would like everyone to perhaps engage in a discussion about what other types of issues might be related to water. For example, when roads flood, how do you get around? What happens when you can't get to where you're trying to go? That's just one example of how other things might be affected by water issues. Or, for example, what does it mean when schools don't have adequate water facilities, either for sanitation or for drinking and eating? What might this affect for the students and the outcomes of their education? If you have other ideas, please share them. Water is connected to nearly everything we might care about if we think about it hard enough. So finally, I want to say thank you. Here is a picture of my research assistants, Zora and Luna. And until next time, I hope you have a lovely day, and I look forward to speaking to you in class. Thank you.